Okay, closed tubes. Now, resonating closed tubes still have to have a standing wave in them. These are like the tubes that we used yesterday when we were playing with the tube in the water. It's open at one end, closed at the other. Closed tubes aren't closed at both ends. One end needs to be open so the sound can get in. So open at one end, closed at the other. Okay? Now, at the open end, just like the open end for the open tubes, there needs to be a node. But at the closed end, there needs to be an antinode. And so the smallest possible wavelength that would fit in here, that will have an antinode down here and a node up here, would look like this. It's closed down here at this end, okay? And so this side, because it's a standing wave, will be dotted. All right, and this is the antinode. This is the middle of the crest or the trough. So this is a half wavelength. So L here, this is a quarter wavelength. L here is equal to 1/4 lambda, which means lambda is going to be equal to 4L. And if we do exactly what we did with the open tubes, if we go to V equals F lambda and rearrange for F to try to find the frequency that'll cause resonance here, F will be equal to V over lambda. And if we sub in the fact that lambda is equal to 4L, then we end up getting F is equal to V over 4L. This is the fundamental frequency for closed tubes. Notice it is very similar to the equation for fundamental frequency for open tubes. The only difference is on the bottom of this denominator is a 4. That 4 comes from the fact that this is a quarter wavelength, whereas for the open tube, it was a half wavelength. Okay, so that's where the factor of 4 comes from. So it's the fundamental frequency, or again, it's the first harmonic, just like it was in the other one. Okay, so now we're going to do the next ones up. So the next one up, the next possible standing wave that it could occur in this tube, if there's a node here and an antinode down here, would look like this. And then when we dot it, like this. Here's the closed end. So this is a quarter wavelength, and this is a half wavelength. So our L is going to be equal to 3/4 lambda, or lambda will be equal to 4 over 3L. Notice that just like in the open tube, we added a half wavelength. So that would make us believe that we would do the same thing when we go to the next one. We're going to add a half wavelength again, because you have to have a node up here and an antinode down here. Okay, and so L will be equal to 5/4 lambda. And in the next one, we will add a half wavelength again, and so it will look like this. One half, two halves, three halves, and another quarter. L is going to equal to 7/4 lambda. So here, lambda will equal 4 over 5L, and here, lambda will equal 4 over 7L. Okay? And so now we're going to do exactly what we did in the open tubes. We're going to sub that in to our F is equal to V over lambda. So we'll end up getting F is equal to V over 4 over 3L. Remember, dividing by a fraction is like flipping and multiplying. So F will equal 3V over 4L. And there's that V over 4L, which was our fundamental. So this F is going to be equal to 3 times F1. Uh-oh, 3 times. In the open tube, it was 2 times for the second one, and then it was 3 times for the third one. But the 2 times is missing. That's peculiar. Let's go look and see what happens next. So when we sub it in again here, V over lambda, we will get V over 4 over 5L, flip and multiply, F is equal to 5V over 4L. There's the V over 4L. That becomes our F1, and so for this one, it's 5 times F1. So it goes 3, 5, guesses for what will be next? Of course, you've already figured it out. It will be 4 over 7L, so F becomes 7V over 4L. This changes to F1, so this F is 7 times F1. So in the closed tubes, the even harmonics are missing. So we don't have an F2. We just have F1, F3, F5, F7. F2, F4, F6, they don't exist. They can't exist. They can't exist because we started with a quarter wavelength. There would be no way you could get F2 and have a node at one end and an antinode at the other. There has to be an odd number of quarter wavelengths to end up with a node at one end and an antinode at the other. And so the fundamental frequency is V over 4L, and then the next 3 harmonics are actually the 3rd harmonic, the 5th harmonic, and the 7th harmonic. And then it would go to the 9th and the 11th. So when you're asked for the next 3 harmonics in a closed tube, you have to skip the even ones. So what do you need to know here? You need to know the pictures, because if you do, then it will be easy to get the equations that connect the wavelengths with the lengths. Okay, so know these pictures, know the connection, know that we're adding a half wavelength each time, and then know the fundamental one, and then it's just going to be times 3 times 5 times 7. Now that you've done this, you should be able to go on and do the examples. Okay, so watch the next video that has the examples, and then do the questions on page 421 and page 427. Please. Thank you.